A world powered by deep technology, enabling a future where we no longer fear cancer, a future where we can ensure sustainable energy consumption and less pollution, and use supercomputers to advance the human condition. A discovery of the DNA structure made in 1953 has made an impact beyond genomics and allowed us to venture deeper into more treatment discovery for all mankind to achieve a future free of avoidable cancer deaths.
Here at Lucence, we work to achieve less suffering and less pain for our cancer patients and their families. This is done through the use of innovative technology for accurate profiling of cancers and more suitable treatments. Amplimark is an advanced next-generation sequencing technology. It is used for the ultra-sensitive detection of cancer signal from a simple blood test. It means the sparing of invasive procedures. We have assembled a crack team of star scientists from 12 countries all around the world right here to make the vision real of a world with no avoidable cancer deaths through the use of non-invasive, innovative blood testing technology.
Innovation has always been the bedrock of human progress. Chemical separation is imperative for industries ranging from food, pharmaceutical, and petrochemical. But the current processes are so energy intensive, they account for up to 15% of global energy consumption. Innovatory technology is necessary to ensure long-term sustainability of these processes while reducing environmental stress.
CPU is providing a sustainable solution to industrial chemical separation. Our new generation of nanofilters will dramatically reduce the energy consumption and pollution globally by enabling the most effective chemical separations at the molecular level without the traditional use of heat. Regular chemical separation processes are not just huge silent polluters, they're also very expensive. That's why CPU's nanofiltration technology is an alternative to reducing the chemical separation's energy consumption by 90%, making it 50% more affordable.
Since the 1960s, digital networking has allowed data to flow between mainframes, terminals, and then computers. The science behind this transfer of data helped develop the internet, cloud computing, IoT, and enabled a digital economy. Quantum devices are not digital, but if we can get these devices to communicate through quantum entanglement, the possibilities they enable may go beyond anything conceivable today.
So Spectral is enabling global quantum communications through satellites transmitting entangled photons, particles of light. This allows quantum devices and future quantum computers to communicate in their native medium. So this enables highly secured communications and eventually a quantum internet and maybe a quantum economy. It may seem implausible today, but so was the digital economy back in the 1960s.
The only thing certain about the future is that it's uncertain. The human race will always reach farther, aim higher, and strive for greater heights. The key to our success lies in the power of deep technology, and the future is up to us now to secure. At SGInnovate, we're making sure that happens, one innovation at a time.
Hi, my name is Carly and I'm 24 this year. I studied law at University of Oxford before doing a Master's of Science in Business Analytics at Columbia University.
My name is Yap Han Ho. I am 27 and I study theoretical physics at the National University of Singapore. At Entropica Labs, I implement quantum and quantum-inspired algorithms to solve optimization problems of industrial relevance.
At Blockpunk, I'm currently working on a classification project, which basically involves using machine learning to classify anime merchandise by title and by product. The startup culture at my company is pretty good. We actually have quite a diverse team of people, and that adds an element of fun to your work experiences.
My startup experience here has been amazing so far. I get to collaborate with industrial partners and work on optimization problems together. They allow us to conduct research independently I feel like it is precisely this confidence that urges me to work harder to deliver results to them.
My mentor actually graduated with a PhD in computer science from Yale, and he's actually very, very helpful without being overly prescriptive. So that sort of guidance is actually very, very useful to young software engineers. The Summation program actually allows for great networking opportunities with other software engineers from different industries. Whereas if you worked in just a startup alone, you might only get to network with your own team.
I would definitely recommend the Summation program to my peers because of the diverse choices that it offers.
Imagine a world filled with endless possibilities, a world powered by deep technology, enabling a future where we no longer fear cancer, a future where we can ensure sustainable energy consumption and less pollution, and use supercomputers to advance the human condition. A discovery of the DNA structure made in 1953 has made an impact beyond genomics and allowed us to venture deeper into more treatment discovery for all mankind to achieve a future free of avoidable cancer deaths.
Here at Lucence, we work to achieve less suffering and less pain for our cancer patients and their families. This is done through the use of innovative technology for accurate profiling of cancers and more suitable treatments. Amplimark is an advanced next-generation sequencing technology. It is used for the ultra-sensitive detection of cancer signal from a simple blood test. It means the sparing of invasive procedures. We have assembled a crack team of star scientists from 12 countries all around the world right here to make the vision real of a world with no avoidable cancer deaths through the use of non-invasive, innovative blood testing technology.
Innovation has always been the bedrock of human progress. Chemical separation is imperative for industries ranging from food, pharmaceutical, and petrochemical. But the current processes are so energy intensive, they account for up to 15% of global energy consumption. Innovatory technology is necessary to ensure long-term sustainability of these processes while reducing environmental stress.
CPU is providing a sustainable solution to industrial chemical separation. Our new generation of nanofilters will dramatically reduce the energy consumption and pollution globally by enabling the most effective chemical separations at the molecular level without the traditional use of heat. Regular chemical separation processes are not just huge silent polluters, they're also very expensive. That's why CPU's nanofiltration technology is an alternative to reducing the chemical separation's energy consumption by 90%, making it 50% more affordable.
Since the 1960s, digital networking has allowed data to flow between mainframes, terminals, and then computers. The science behind this transfer of data helped develop the internet, cloud computing, IoT, and enabled a digital economy. Quantum devices are not digital, but if we can get these devices to communicate through quantum entanglement, the possibilities they enable may go beyond anything conceivable today.
So Spectral is enabling global quantum communications through satellites transmitting entangled photons, particles of light. This allows quantum devices and future quantum computers to communicate in their native medium. So this enables highly secured communications and eventually a quantum internet and maybe a quantum economy. It may seem implausible today, but so was the digital economy back in the 1960s.
The only thing certain about the future is that it's uncertain. The human race will always reach farther, aim higher, and strive for greater heights. The key to our success lies in the power of deep technology, and the future is up to us now to secure. At SGInnovate, we're making sure that happens, one innovation at a time.
Hello everyone, a very good afternoon to those who are joining us from Singapore and Asia, and good morning or good afternoon to all, good morning or good evening to all of you joining us from other parts of the world. Thank you for being here with us for today's online event on the future of food, printed meals, presented by SGInnovate and partnered with the Embassy of the Kingdom of the Netherlands in Singapore, the Netherlands Innovation Network, and the Singapore National Additive Manufacturing Innovation Cluster. My name is Jin from SGInnovate, and as a Singapore government-backed investor, we have been building up and driving deep tech innovations in AI, healthcare, quantum tech, food and agri-tech, and autonomous technologies across various industries. At SGInnovate, much of our work is to connect Singapore with the global deep tech ecosystem to learn how we can better harness technology for a more sustainable world. Today, we have our panel of experts from Singapore and the Netherlands to talk about the advancements in the world of food printing and how printed meals may become the future of our foods. We encourage you to engage with our speakers during the session by submitting your questions in the Q&A box located on the lower panel of your screen. Before we start the session, I would like to invite Sabine from the Netherlands Embassy to give us a quick introduction about their work. Sabine, please. Sabine, I think you're muted.
Sorry about that. Thank you, Jin. Good afternoon to everyone and good morning for those in Europe. And welcome to yet our last webinar of the future of food. We've had 5 amazing webinars with all fantastic speakers whom without them, this webinar session about the future of food wouldn't be such a success. But surely also not without our friends from SGInnovate, Tuan, Siki, Jody and Jin and everyone else that I'm now forgetting to mention. Thank you. Also thanks to the audience of previous sessions that have filled in the surveys that we have sent around. We've been able to build a network document which we can use to update you about following interesting events. Also after this webinar, an email with a survey link will be sent to you with a kind request to give us feedback. About interesting events, last week the Dutch Ministry had the official kickoff for their virtual economic mission to Thailand, Indonesia, Malaysia, Vietnam and Singapore, or as we call it, the Asian 5. The mission is aimed to facilitate Dutch companies and companies from the Asian 5 region in gaining market information and new business contacts in agri-food, water management and circular economy. For agri-food, we are zooming in on ingredients for food and feed, post-harvest technologies, and the water agri-nexus. Join us in informative webinar sessions and online matchmaking to learn more about the Dutch agri-food, water tech, and waste management throughout the mission period. Southeast Asian participants can register for free of charge. If you want to know more, a link with more information will be shared after this webinar by email. Besides the Asian 5 mission, the Dutch Embassy is also organizing a pitching session for Dutch food tech startups active in alternative proteins and sustainable food production to present themselves to potential investors and industry partners in Singapore. Interested to hear more about these amazingly innovative companies, join us on the 12th of November for the pitching sessions and matchmaking. A link with more information will be shared afterwards. And now it's time to start our panel discussion with the future of printed meals. With our panel of experts, Elsa Linde from Upprinting Food, Dr. Lee from A-Star, and Annie from Enrich 3D. Over to our moderator of today, Michael Patch. Michael is editor-in-chief at 3D Printing Industry and the author of several books on 3D printing. Michael is also host of Another Dimension, a 3D printing focused podcast. Michael, the floor is yours.
Thanks, Sabine. Yes, that's right. So welcome to today's panel discussion on the future of food and 3D printed meals. As Sabine mentioned, I'm the editor-in-chief of 3dprintingindustry.com, and we are the leading source for additive manufacturing news and analysis. Now, today's topic is maybe a little bit more esoteric than our regular bread and butter, so to speak, where we focus on aerospace, medical and defense, but it's no less interesting. And I'd like to thank our hosts at SGInnovate for putting together this event. As you've heard, there will be a Q&A session at the end of the panel discussion, so please do send us your questions in the question and answer box that can be activated by clicking at the bottom of the Zoom window. So when I was researching a book on this topic in 2015, I found a handful of companies who were active in this space. At the time, the Foodini 3D printer had made its way into high-end kitchens in Barcelona as another tool in the chef's arsenal. And I also found that scientists in the UK were investigating how to introduce cellulose, a non-digestible plant fiber, into cakes and biscuits as a means to introduce satiety without the calorific input. In Germany, we saw a company called BioZoom who were deploying 3D printing to create meals for elderly care home residents. More recently, Redefine Meat has raised $6 million. This is an Israeli startup who have promised an alternative meat 3D printer last year, and that printer's yet to materialize. But elsewhere in Vienna, there's a company called Legendary Fish who claim to be producing a plant-based 3D printed salmon fillet as a sustainable solution to overfishing. So what substance is behind these techno-utopian visions? Can 3D printing provide a personalized nutrition solution? Are we likely to 3D print food in our homes at any point in the future? Well, or maybe there's a danger that grafting together these themes of sustainability and technological solutions blinds us to a truly scalable method of averting environmental catastrophe. Well, let's get into some of these questions today. And with that in mind, I'd like to bring on today's panel, who are, we have Elselinde van Dolwerd, who is the creative director and founder of Upprinting Food. We have Dr. Lee Munwai, who is the Senior Technical Lead of the FMG Cluster Advanced Remanufacturing and Technology Center at A-Star. And also we have Anirudh Agarwal, who is the founder of Anrich 3D. So welcome to our panel today. And hello, everybody.
Hello.
Greetings. Greetings.
Hello,
so thank you all for joining us. Before we get into the main discussion, I'd just like to take a moment for you all to introduce yourselves. So Elselinde, welcome to the panel. Perhaps you could tell us more about yourself and Upprinting Food, please.
Thank you for inviting me. So I'm Elselinde. I'm founder of the startup Upprinting Food. I'm also a master's student in industrial design at the Eindhoven University of Technology. And with Upprinting Food, we're focused on actually reducing food waste by 3D printing. So we're 3D printing food from products like old bread, fruit, vegetables that are normally often thrown to waste. And actually, this way we can really create some new value. We can change the appearance of the food. We can show people how this food can still look attractive and actually also is tasty. And yes, that is what we're focused on and trying to make the first steps in reducing food waste by 3D printing.
Marvelous. I'd love to get more into that topic in a bit. Now, also, Munwai, perhaps you can tell us what's A-Star's interest is in this topic.
Right. Basically, I'm actually a senior food tech in this era A-Star, but what really happens is I'm actually going to do some presentation of my previous experience where I deal with personalization of silver age foods. So predominantly what we did is we designed personalized nutrition for the silver menu. Right, and it's actually primarily focusing on the Asian or if not the Singaporean population, recognizing that we are actually undergoing a silver age or aging population here. Right.
Excellent, excellent, great. Well, I think that's a really fascinating topic. We'll come back to that in a bit. And by no means least, we have Anirudh Agarwal, who's the founder of Anrich 3D. Maybe you can tell us a bit about yourself and your company, please.
Hello, everyone. I'm Anirudh. I'm the founder of Anrich. We are working on food 3D printing for personalized nutrition. So how that works is you take different ingredients and print them in the precise amounts according to the requirements of the individual. So that is optimized for the nutritional requirements, which is what 3D printing makes possible.
Marvelous. Well, welcome all. And please, if you're listening wherever you are in the world, don't forget to send us your questions. So let's get a bit more into detail this. So Elselinde, you mentioned there reducing food waste. What sort of quantities are we talking about? How much food is wasted, and how do you help to address or hope to address that issue?
Well, really a lot of food is wasted. So I'm from the Netherlands, and the most wasted products over here are old bread. We eat a lot of bread here every day. People are eating bread for lunch in the morning, and actually, we also expect people to eat and to buy fresh bread. So at the end of the day, all bread is thrown away in the supermarkets, in bakeries, in restaurants, and next to that, fruit and vegetables. Just when they are not beautiful enough, we don't buy them in the supermarkets anymore. When they are not beautiful enough in a restaurant, we don't serve them anymore. So really, a lot of food is thrown away. Like 1/3 of the food we produce is actually thrown away, which is really a lot. So what we do actually, we started working with high-end restaurants, with chefs, and actually inspired them to reduce their own food waste by 3D printing with it. So we show them how they really could start reducing their waste, reducing their old bread, not throwing it away, but making purees to start printing from with a 3D printer in shapes that were really fitting their restaurant, their company, so that they could also show something special to the guests in the end and even inspire them to be creative with the food they normally throw away. So that was actually the start of our journey, and now we are also trying to upscale this, but I think we will come back to that later on in this session. But yeah, there are a lot of potential in reducing this kind of food waste, especially because we really can change the appearance of the food and the structure, and also inspire people to look more creatively in this kind of products.
So what kind of printer are you using? Is this a customized machine you've built? Is it sort of an FDM based printer, or how do you technically do this?
Yeah, well, we started indeed with just a normal printer that was adjusted for food. Um, like how I sometimes explain to people what is actually this kind of food printing is actually, I started myself with a piping bag. So for chefs, it is kind of clear, and how you can envision with a piping bag, you can make shapes. Not as precise as with a 3D printer, but you need to put pressure on it to get some puree out of it. Then a 3D printer is actually a sort of piping bag. So we have a syringe in which we can put a puree, and then it's moving on 2 axes. And by putting pressure on this kind of puree, it will come out. And by actually programming the shape, it can also really look attractive, and we can make lots of the same kind of samples that are exactly the same. So that is how it works.
Okay, so I've seen similar sort of approaches applied with ceramics, and you mentioned there's a pressure system that then pushes the material through into a nozzle and it's laid down. So it's a sort of modified FDM type system, I would imagine.
Yeah.
And what's specifically, what kind of things are you printing with this this puree?
Well, we started off with a combination of all bread, fruit, and vegetables, and making like cookie and cracker structures. Also because we then bake them afterwards and actually dry them, dehydrate them even, to give it a long shelf life, which is important when you are aiming to reduce waste, of course. And now we are also working with a lot of creative chefs that are doing different kind of things. So more for desserts, for jellies and stuff like that, but all with products that are normally often thrown away. Even with banana peels, for example, fish skins, and that kind of crazy products, which is really great to see.
Great. Okay. So, tell us a bit more about the work you're doing and work you've looked at in the past on 3D printing and food, and how these two things, which may seem not to go together, why have you put them together, and what's the interest here?
Right. Primarily, what we call for the project that we developed is actually a silver menu. So because we recognize that Singapore is going to hit 900,000 senior citizens by 2030. So and I would be someone who would be tasting some of those foods, and I would think that I wanted something that is tasty and healthy as well. So we designed something that is called Aging Gracefully for the senior citizens in Singapore. So what we did is we looked into co-creating the products with our senior citizens. So what we did is really to walk with them through what we call a design thinking approach. So we co-create a product and ask the senior citizens what is it that they like, and what is it that they desire to eat and cannot consume. So typically in the Singapore aging population, they do have high cholesterol, diabetes, and they are also having a high blood pressure as well. So this actually refrained them from eating durians. I'm not quite sure if the population over in the other part of the world like this delicacy. Of course,
I like it. I actually like it. Yes.
That's good. Some of them think that it has a very offensive odor, but to us, we find that it's very aromatic, that aroma is really good. So, and that is something that the silver age is deprived of because of the high potassium, and it is overly sweet, and they are unable to do that. So we brought it back to our table, and we designed something based on the 3D printed food, right? Modifying the product, giving it certain extent of delicacy, and of course also pumping it with what we call nutrients through fortification. Yeah, so this is also an extrusion-based process then? Yes, correct. We try to feel, because what we are more interested in is really to design the food part of it. So we're using commercialized systems. So we have Bucosini, we use Biflow, we also use a different system like Foodini as well, right, to try to come up with different types of printouts to make sure that the food, like what Alexander says, is look nice and palatable, so that the silver age loves it. Because at this current point in time, most of them have swallowing issues, and whatever that a gluey pump of food that doesn't look nice, and they have to swallow it. And through the feedback from what they have actually given to us is like they need to look good before they want to put it into the mouth. So the medical term is dysphagia, isn't it? Right, the dysphagia patients, yes, specific for that. Correct. And someone who's on the onset of dysphagia as well, some of them are not diagnosed, but they do have a bit of swallowing with aging issues. So the swallowing itself will tend to choke them up. That's why we are looking at that. And why is it not possible to produce food which is appealing in another manner other than using 3D printing for these residents? We are able to do that. We actually have molded foods as well, but using 3D printing itself, right, is able to enable us to do an automation. Because apart from this silver menu, what we did is we actually looked at the on-demand printing. We had a watch that measures the requirements of an individual, and based on the losses of the moisture, because we are at this present point in time when we developed it, we look at hydration of any human. So it could be an athlete who has actually did their workout and has actually lost quite a bit of water. So that it will be detected by a wearable, and the wearable will communicate with our printer. And when the person reach home after the exercise or the workout, then the menu will be printed to them according to the needs. So this is looking at the aging population, working out a way to actually help them with automating what would otherwise be quite a labor-intensive sort of endeavor. Right. We are also looking at that because as you age, your ability to cook meals and stuff, you know, is a bit more cumbersome in that sense, because the strength of the individual deteriorates with age, right? And also sometimes most of them cook very small portions, and they may not be able to cook a sumptuous meal for themselves. But if you do it into a printer where you have different syringes, they are able to, based on the recipe and the requirements on the individual, have it printed nicely in one single meal, so that they do not need to keep washing the pots and pans based on that. So that is something that our Silver Age actually welcome as well, because things is just like a printer. You just click the send button and then I've got a printout there. Just that right now I'm able to consume it. So that's what they think that, wow, I'm moving a computerized paper to a piece of meal. So it somehow fascinates this group of people at this point in time that to them, printer is always print out from the paper and the computer. It always relates to digitalization or digital printouts. But right now we are looking at meals in terms of that. Yeah. So when we actually talked about wearing a wearable, there is less resistance as well. You know, when we actually do idea conceptualization marketing, we say that if you wear it and you do for a walk, when you come home, your meal is already printed on, and you just need to fetch it out of the printer and you have it. And they just seems that it's like something of the future, which is what we are talking right now, the future of printed foods. Right. Well, yes, I wish it was always as simple as just pushing the button. And I've often walked into the office in the morning and found 3D printed plastic spaghetti, but in this case, we're talking maybe literally coming into printed spaghetti. But anyway, let's Sorry, Aniruddha, we've been neglecting you a little bit, but perhaps you could tell us why you started Enrich 3D and what stage the business is at, please.
So like you mentioned, you also started looking into 3D printing in 2015. That's when I came to Singapore and I started my master's thesis on food 3D printer head design. And that's when I looked into some of the applications. And in 2018, I joined NTU University as a mechanical engineer to build a 3D printer to commercialize it for various applications. So it's not just personalized nutrition, but a lot of different applications that we can do using 3D printing, as is clear from this panel right here. What I'm trying to do is make an industrial size machine which has a continuous feeding capability, which would allow us to not be limited by the size of the machine to print large meals, and allow us to keep printing lots of meals so that we can eventually provide personalized nutrition at scale. And when it is at scale, using economies of scale, it will be affordable and available for everyone. So that's what we were focusing on. Right now, we are making the first food safe prototype version. So I'm very focused on the 3D printing technology side of it, as opposed to most other companies that are using off-the-shelf printers or like ready-made stuff.
This is very interesting, but I'm keen to hear how you plan to scale this, and what's the technology platform you're using to make this this reality.
Well, 3D printing is in general a well-established technology. So there are a lot of off-the-shelf and freeware software and firmware that is available. Lots of highly compatible electronics hardware is also available. So we just start with that, try to make a prototype which is food safe and is compatible with chefs using it for large meals, and then being able to wash it so that the whole process is food safe certifiable. And from that point onward, then we can get into more sophisticated algorithms for personalized nutrition, or for being able to choose different types of meals. Another thing that was striking to me when I was looking into 3D printing applications was that most of the 3D printers were being used for making designer shapes, and it's a machine, and it should logically be better at doing math and measurements than people. And people were figuring out how to do the maths for the machine to work, and the machine was doing all the art. So what I hope to achieve is that the chefs and the people are focusing on what type of recipes, what type of creative, how do they flow their creative juices, and the machine will be doing the math for them so that it can produce optimized meals according to everyone's requirement. Now,
Okay.
I'm from mechanical background, but there are a lot of nutritionists already out there. So nutrition-based personalized advice is already available. We can just convert that into actual meals.
I mean, for people listening and watching who are maybe not so familiar with 3D printing or additive manufacturing, as it's also known at the industrial end of the scale, we're not just talking about a single technology here, are we? We're talking about, I think, at least 7 different categories. So within additive, you have your technology that can work with plastics, technology that can work with polymers. I'm sorry. Polymers and plastics are the same thing, metals and ceramics. So you have, things using lasers, things using electron beams. And when we talk about FDM, we're talking about extrusion-based technologies. Is your technology an extrusion-based technology?
Yes.
It is. Okay. So we'll probably get more details of that a bit further down the road. So thank you for telling us all about everything bits of what you're working on. The key question for me I have really at this point is, why 3D printing? Often when I sort of see projects in the wider world, people are very excited about this, what can be described sometimes as a frontier technology. But is 3D printing really the best solution for this? Why have you chosen to use 3D printing in your work? So perhaps let's start with Alsalinde on this one, please.
Well, actually, I started with the idea of reducing food waste, and because of my background of industrial design, I came into contact with the technology of 3D printing, And this was a nice way to actually serve the food in a different appearance, because we can really change the appearance of the food. Most food products are thrown away because they're just not beautiful enough. And by 3D printing it, we can really upcycle it in a way that it's looking attractive again. And then people started looking differently, started talking differently at it. In the beginning, I didn't tell people that it was made from this kind of wasted products, because while it was so attractive, people were really willing to eat it. And then afterwards, started discussing about it was actually made from those wasted products. They also dare to start this kind of discussions about food waste and actually start seeing the value of it instead of throwing it away. And I think that's really important part for me. Next to that, also we can really change the structure of the food because of printing layer by layer and baking it afterwards. We can find a way to create more crunchy food products without adding any not natural additives, for example. And we also don't have to use a lot of fat or things like that to create crunchy cookies in the end. So we can really use a lot of food waste, like more than 90% of the food from one cookie is made from all the fruit and vegetables in the end.
Munwai, you mentioned automation being one of the benefits here of using 3D printing. Does your process harness any of the other sort of advantages we see of additive manufacturing in the industrial sector, such as geometric complexity, sort of design freedoms, these kind of strength to weight ratios? Is that any of that important in the food area, or is it the automation angle that's the most key?
All right, for us, what really happens is we wanted to look at automation to have an automated kitchen for the silver age. It can be actually applied to any other technologies like molding as well. But we see the essence of minimizing manpower so that it's easier for the food preparation processes itself. But during the course of research that we did, right, geometry is something that is also pretty sensitive, because we tried to build a castle with actually an incremental height, and our food just collapsed. So it just went a puddle. Our castle was building right by the fourth or the fifth layer. It started to tilt like a tower of Pisa, and then at the end of the day, it just went flat on the plate itself. So there are some issues that we need to look at. So within that particular element, we actually look at the process buildability and also the food nature of the foods. Because if you're looking at highly liquefied foods, right, it is not able to offer the height that we wanted. And of course, then you will not be able to provide very nice, aesthetically nice food that has a height. So it has to be pretty flat. It has to be a bit quite 2 or 3 layers itself, right? Over time, we actually observe that the food will start to go, the shape will go, and then it flattens off, and at the end, it doesn't look good. Yeah, so that was something that when we study the interaction between 3D printed foods and the nature of food itself, is something that is worth the research on. That's what we are looking at. Yeah.
Okay, excellent. So, and Anirudh, why have you chosen 3D printing as the technology to sort of build your business on?
Well, there's no alternative to 3D printing when it comes to the level of flexibility that it offers. Even in the manufacturing in general, we use 3D printing for applications where no other manufacturing process can do that kind of shape. Another reason we use 3D printing is in manufacturing is that when we are producing one-offs. So if it is only one item, then it doesn't make sense to make another machine, configure another machine to do that, just that one item. It becomes too expensive. So if we want to make personalized nutrition available and affordable at scale, we need each meal to be unique, but still be able to somehow use the economies of scale by one machine being capable of a large variety of operations. So that's how, with many materials and large scale, we can have a single 3D printer produce a lot of different kinds of meals.
Okay, so you mentioned economies of scale there. I'm interested to hear about the Anirudh 3D perspective, but also from the other panelists on this. What kind of impact and how large can these solutions go? Is this a scalable sort of approach? Perhaps Anirudh, maybe you'd like to take that one first, and then we'll move on to the other panelists.
Okay, so how Enriched is picturing how it's going to be is having centralized manufacturing facilities where we have a lot of food 3D printers working together. And if in one location there are different businesses like hospitals, gyms, schools, offices that require 3D printed food, personalized nutrition for their employees or patients or whatever the case may be, we can use that same manufacturing facility to service all those in the same area. The same printer could be producing one meal that goes to the hospital and the next meal going to the school. So that kind of flexibility will allow the economies of scale to actually exist in this kind of business.
Okay. And Aslinde, what are your thoughts about how you can scale your technology? Is this beyond working just with restaurants? Is this something that has a wider applicability?
Yeah, for sure. Like within our team, we have 3 engineers who are also working on their own printer now to try to at least upscale it in the first steps to produce more samples at the same time. And then on the other hand, we are also now trying to set up larger corporations with bakeries, for example, to see how we can reduce all bread waste with this kind of technologies. It is still a challenge because it's not like we can already buy this kind of printers that are widely available with the extrusion technologies. On the other hand, we already see in the supermarkets right now cookies that are made with extrusion that are similar kind of technologies, but not that refined. So for sure, there are a lot of possibilities. And I think just by developing those, we will see how that will turn out, but we definitely can reduce more waste on a larger scale with it.
Thank you. And Munwai, what are your thoughts about this area?
For us to deliver personalization, we actually map out that other than the elderly, we do the other full swing. We look at infants, we look at kids and toddlers, and especially if you talk about kids and toddlers, they simply detest vegetables and fruits. So if you could print them in like interesting, maybe the cartoons and in terms of figurines that they like, I think the receptiveness to the food that they hated could be actually be reduced. So that's one that we looked at. Of course, nursing home is like what Adif has said. I think that's something that we also decided to look at. And the other one that we thought of could be the athletes. So for example, for the athletes who need certain performance nutrition, certain performance caliber for the fortification that they will require. So that's somewhere we can look at the sports schools, for example, right? So these are some of them. And we even have a wild thought of how about bringing it to the aircraft meals. You know, so that when you actually place an order, you can see the meal being printed out by placing a camera on the printer itself, and then after that they will be served to you. Of course, things that needs to be adjusted is definitely the texture, the flavor, and of course the palatability. Yeah.
Yeah. So I'm interested to hear you. You were talking about sort of the one of the consumer groups who's notoriously picky. That's children, and can be fussy eaters. But also society's tastes and trends in certain parts of the world are shifting towards natural and organic foods. With that in mind, what is the consumer perspective on 3D printed food?
We have ever spoke to them before, because what happens is the food that is prepared, right, is actually pureed from fresh foods. So in terms of the receptiveness, it's actually considered not so processed in that sense. There is no heat treatment or any other treatment that is done to the foods. I think the receptiveness was pretty good when we spoke to them about that, right? The only concern that we have is if we want to have very long shelf life, because you have to have pureed foods, right? Through oxidation, the nutritional contents and all the tastiness, the oxidation will kick in and it will compromise the quality of the foods. Then, of course, processing will have to come in. So you can actually dehydrate it to form it into a powder, for example. That's one way that you can look at it, and only rehydrate it when you want to prepare the foods. Then you'll be able to have a freshness and natural ingredients offered to the table only at the point of printing. Yeah.
And Elsalinda, does that match your experience speaking to consumers?
Well, partly like what we do by working with those kind of ingredients, we teach chefs how they can really reduce their own kind of waste products. And every time that there are different kind of products, So often they're fruit and vegetables, and we need to make sure, of course, that it is fine to eat, and that we don't get sick from it by serving it to other people. So there are different kind of preservation methods to make sure that we can make a puree out of it, and also that it is fine to eat in the end. And for example, by fermenting products or by just cooking products by making a puree out of it. Old bread we first dehydrated to make a sort of powder from it, and then we combine those kind of ingredients. But for example, with bananas, brown bananas, we can just make a banana puree out of it. We mix it with the old bread, and then it's fine to print in the end. So we make sure that we use natural ingredients and no additives or anything like that. And that is also tasty, of course, when working with chefs. That's very important factor.
Okay, let's sort of maybe jump ahead into the future a little bit here. And we've been talking a lot about what's been going on, what's gone on in the past. I'd like to maybe get a bit more into where this is going and look at sort of the frontiers and where this might go. So, and Anirudh, we were talking offline a bit about the future of some of these ideas, and I think you brought up alternative meats. Perhaps you could tell us a little bit about that area.
Yes, so alternative meats, when you're trying to make something that that already has internal structure, you can't do that by just mixing everything in one puree. It will have a consistent texture and flavor if you do that. But if you are able to place the ingredients in the right place, having layers of fat and protein arranged in the right way so that it resembles how it is like in an actual animal, that would be what the alternative meats are, meat companies are trying to achieve. So that is something that necessarily requires 3D printing, and that's what we would be trying to offer as well. As a general purpose printer, we can customize it a little bit for alternative meat companies as well.
So what are the inks, if you like, that go into an alternative meat in this this kind of scenario?
Well, it depends on the type of company. Some companies are working on making just scaffolds with 3D printing and then growing the cells on them. So in that case, the ink is not going to be the actual meat. But in other cases, we have plant-based options for plant-based alternatives for the individual components like the fat, meat, and the flesh and all those things. And they just arrange that using the 3D printer.
Yes,
so it varies.
So one company which springs to mind there was, I think, an offshoot of Organonova, who were making sort of medical and sort of bioprints, but they also stumbled upon a technique, or developed a technique rather, to produce something which they call cultured meat, and it's not a term I particularly find appetizing. And this was to do with aligning stem cells and then emerging the resulting scaffold in a nutrient bath, and then stimulating that via an electric charge to create tissue. So that raises some interesting ethical considerations. You know, if you're a vegetarian or you don't eat meat for religious reasons, can you still eat cultured meat? Also, you know, you have to think, well, is this scalable? But the plant-based methods as well, you've spoken about. Yes, I've seen that company Redefine Meats in Israel. They are one company who are pursuing that approach and layering their prints with material to represent fat or represent muscle, and to get that experience. I was wondering, Rosalinde, have you come across any other interesting future applications of sort of real sort of cutting edge stuff?
Well, we're working ourselves now on shape-changing food, also with a 3D printer. So that is a really nice new topic, by 3D printing with a material which actually reacts when you pour a sauce on top. So then it starts changing in the end. So then it's more like a new dimension, actually 4D printing, which is really cool and a new area to discover and kind of exciting also for the high-end restaurant industry. to create new kind of dining experiences, of course. So
Yeah, wow. So that's kind of like Heston Blumenthal sort of molecular gastronomy type area
yeah,
you're looking
something
to.
like that indeed.
Yeah. And for those who aren't familiar with 4D printing, maybe you could quickly give us a summary.
Yeah, well, actually, when you're printing, often like with a normal printer on paper, you are printing just one layer, and then when you're actually extruding it, then you already have 2D, so you can view at it from two different kind of perspectives. And then when you really can create different kind of heights, you have 3D. But then also when you have an aspect that is can still change in a different kind of shape, for example, that it has another kind of dimension even, then you have 4D. So that is what we're envisioning and really looking forward to see more of those kind of projects in the future. And we see it a lot already with textile printing, for example, that kind of materials. And I think food printing is a new kind of area also within this topic.
Yes, I think Skylar Tibbetts in the US is a key proponent of 4D printing, and especially in the sort of construction and architecture realm. Now, Munwai, I'm sure A-Star has some interesting insights into where the future of 3D printed food is going.
Right, because what happens is at this point where I'm working on, we are looking at probably mass production of the personalized inks. That's something that we wanted to look so that we are able to allow 3D printing to reach out to a greater population. So we are working on automation processes that delivers food inks that is available for 3D printing. That is what my current research work is on. Yeah, and one of the type of inks that we are looking at is actually alternative protein inks, so that we are able to deliver alternative proteins or otherwise, for example, healthier cultured meats, for example, as well. But we are right now building into ink production so that we are able to reach out to a greater population.
Okay, so you mentioned, did you mention cultured meats there? Maybe you could tell us a bit more about that work, because that sounds quite interesting.
Right, we are not exactly, okay, there are researchers or my fellow colleagues who works on cultured meat. At this point in time, what we wanted to look at is, for example, to how to automate the processes of like demolding, for example, so that we are looking at using robots to try to automate the production processes of it, rather than looking at the meat or the formulation part. So we wanted to use 3D printing on a reverse side and to try to look at that. Yeah.
Okay, right. Now, before we get into the Q&A session with the wider audience, I wonder, do the panelists have any questions for each other you'd like to ask about each other's work?
I do. Can I check?
Yes.
Alexander, what is, how tasty are the foods, right? Did you taste them yourself?
Sorry, did you ask it to me?
The food that you have actually printed?
Yeah.
Yeah. Are they tasty? What
yes,
consumer,
like they are served in Michelin star restaurants, so it would be a shame if they are not tasty in the end. And well, they can try to give their own flavors, own recipes, but we really learn them to create it themselves and actually to start thinking more creatively. And actually, every restaurant wants to create something unique, so not the same recipe as any other restaurant, which is kind of challenging, but really interesting, and always really nice to try the new kind of recipes that they discovered.
What was the reaction of the consumers when you tell them actually these are foods that are rejected? Well, eat it on a plate. So how do they?
Yeah, well, that was in the beginning, like when I just finalized my bachelor with this kind of project and did some user tests. And actually, it was kind of funny because those people were, well, very positive already about the 3D printing aspect of the food, about the appearance, and then also about the flavors. And they were asking for more of those kind of products that they could taste more. So they really were positive. And then in the end, I was like, okay, and those products are made with bananas, banana peels, old bread, carrots that are normally thrown away. So then we could really start a sort of discussion, which was actually kind of nice, because then we could also argue, why do we normally throw this away? And it seemed that people actually were turning more positive towards this kind of normally wasted products, which was really nice. And we had a kind of good conversation. So yeah, it was nice. It was challenging and interesting to set it up this way, but it's a really nice outcome.
Yeah, great. Look forward to
Excellent.
taste them as
Right.
well.
I think it's time to get into the Q&A session. We've got some very inquisitive people in the audience today, so we've got a lot of questions to get through. So if you can keep your answers relatively short and concise, we'll try to get through as many of these as we can. So to kick off, we have a question which says, what is stopping a company like Impossible Foods or Beyond Meats from creating products with 3D printing? If they were to enter this space, how will new startups compete? And who would like to tackle that one?
Yeah, I think, well, what is stopping them right now is just the scalability. So the startups that are up to now to create this kind of meat or meat replacements are actually developing now this kind of structure. And I think that works quite well with one printer. You can really do this kind of development, but then they are challenged towards the upscaling of this. So as soon as it's possible to upscale this kind of products, I think then it's also not stopping those kind of companies to take the same kind of challenge, or maybe partnering with those kind of startups to create even better structures in the end.
Yes. Okay. So I imagine you may have a perspective on this as well, Anirudh, as a sort of startup yourself.
Yeah, I was also thinking how we can protect against these companies coming up with their own printers if they do. But then I thought about their focus is going to be as a startup. I try to focus on just developing the printer for myself because that's my core competency. So I think that the alternative meat companies are also going to focus on related applications and just making different types of meat structures instead of going into general foods or general like printer production.
Okay, right. Next question comes from, and I apologize for my pronunciation in advance, Adrian Vanden Broke, who says, I see the usefulness and simplicity when using a food printer. However, I'm not sure I understood how it can help with food being thrown away. Could you explain more, please? So I think that one's probably directed at you, Celinde.
I think so as well. So I hope you already have more explanation during this conversations we had. I think it's mostly focused, at least what we're doing is on inspiring people this way by looking at the food products they are thrown away because they're not beautiful enough. People think they're not tasty anymore. And just by changing this kind of conversation in a way that we can show that they are actually tasty, that they actually can be really beautiful, and that they actually can be very valuable products. And this is with the use of the 3D food printing, which is a key aspect in changing the appearance of the food and by convincing these people.
Okay, next question comes from Wan Shoot, who says, a lot of research and development has centered on extrusion-based 3D printing of food. What are the panelists' thoughts on the scalability of this technology compared to other alternative, more scalable printing methods, e.g. binder jetting 3D printing, and indeed, 3D Systems acquired ChefJet, which was a binder jetting printing company. Perhaps we can hear from Anirudh on this one, because I think you're looking at scaling, aren't you? And what are your thoughts about how to scale and also alternative methods which are not extrusion based?
Yeah, so there, unsurprisingly, since 3D printing has existed for a long time, there are a lot of different methods in which things can be 3D printed. So even with food, you have, of course, the extrusion is the most common process, but we also have laser-based and binder jetting-based printing methods. So in terms of manufacturing, the most scalable 3D printing process is the binder jetting, or something that is that has a large powder bed on which you can laser or bind something. That allows you to make lots of products on the same bed at the same time, going one layer at a time. But that does not allow you to really use multiple materials as easily. And it also restricts you to the types of materials that can work with powders. And again, there's also a lot of wastage in that in that process, because all that powder that has once been used, it cannot be used again.
I wonder, Dr. Lee, what your thoughts are about relying just on extrusion, which isn't a particularly scalable sort of process, as is widely acknowledged.
Yeah, for mine, I believe the choice of extrusion is because it's easy to handle. Because if you're talking about binder jetting, I think it could have to come in the form of a particulate. So when you talk about food, if it's highly fluid, right, it may not be able to offer the type of precision or in fact the type of ejection speed or in fact the type of dimensions that you want it to be as well. That is to my limited knowledge, but I believe that it's because of the type of product that you're putting into the printer, it limits the choice of the processes. But of course, I do understand there are a lot of researchers is working beyond extrusion techniques as well. But at the current point in time, from what I understood based on our research, is extrusion is one of the fastest way and is more complementary to the nature of foods.
Okay, interesting. Here's another question from someone who will be no doubt familiar to everybody watching and the panelists. So Olaf Diegel asks, I would like to get your thoughts on using 3D printing for the sake of 3D printing, particularly if it is just for making foods look pretty rather than using other more time/cost efficient methods like molding or even 3D TI, which is an automated system with 3D printed molds and automated filling and packaging line. If a food has individually customized ingredients, then it's another story, of course. So yes, as we said at the top of the of today's panel, is this sort of techno-utopianism? Is this just printing for the sake of printing? What are the panelists' thoughts on that?
I think that's not only for, well, the sake of printing, like we really can, what we do is creating an experience with the food printers, even by putting them in the restaurant, showing people how the process works, and in the end serving it on the plate. And I think it's important that we can show this entire process, that we indeed also have the aesthetical pleasing aspect, maybe even the structure, because the purees we are currently using for 3D printing, if we just spread them out and bake them, then they won't be crunchy at all. But on the other hand, I think you're right that there are possibilities as well with molding to reduce food waste, but we have to change the recipes, we have to do more research into that. And I will say, like, when we now are more focused in reducing food waste on a higher scale, then we for sure can also look into this kind of techniques to see if we can make the same kind of beautiful shapes and reducing more food waste in the end, because that is most important then for us.
Do the other panelists have something to add into this? Are we just printing for the sake of it, or is there a wider reason?
Well, in terms of the capabilities of 3D printing as a manufacturing process, it allows for using layering of different ingredients in such a way that you can get a unique flavor profile or unique structure, like for alternative meats, and there's just no other way of doing it. So it is not just for the sake of it, or just for aesthetic purposes, or for vanity purposes, or whatever. It does have actual applications, and that's why we focus on it.
I mean, I can understand why 3D printing is a very exciting technology, and so anyway, they've got a couple of questions I think we've addressed. So we've talked already about the materials that can be considered for printed foods. We have another question from Nizon Low, who is interested in the commercial elements here, and that person says, I would like to find out what might be some of the potential development and market opportunities for 3D food printing. So some insights in where the money's going.
I think it's nice also to discuss, like, do you think, like, for the other panelists, that in the end we will have those kind of printers in a home kitchen, that people are printing themselves? Because this is a topic that is, well, often discussed and often asked to me. I don't think this will be happening, that we are printing our own food in our own kitchen at home. It will be time consuming, but I'm very curious to how you're looking at this.
Well, if I may interject here, I think that there are there can be a lot of different stages in which this technology can develop. And at the first stage, like what we are at right now, we can just have meals being printed, and the engineers and the people who are developing the printers can take care of operating the machine. But as the technology develops further and more people adopt it around the world, it will become more user friendly and easier to operate. And we can eventually add more and more automation to it, so that eventually it becomes at a level that people can operate it in at least an office setting or a vending machine setting, if not at home. Because the machine, if you want to have like several different ingredients as an option, if you want to make like a real meal, then you would want to have like a very large machine. So I don't know how feasible that would be. Maybe people could replace an entire kitchen with that or something, but it is something that could eventually be done. It depends on how the technology develops further and how many people want to use it.
What sort of
I
time
like
frame are we talking about here? I mean, are we getting close to tea or grey hot at any point soon?
I would say that it also depends very closely, or it's very closely tied with the development of space exploration. Because when we use 3D printing, we have to convert things into paste, and we might even start to develop technologies where we start with powder form and use water to make the paste and then recycle the water. So that would make the food preparation process very efficient, kind of like the Star Trek food synthesizer. And if that happens, then food 3D printing would explode in popularity and applicability, and it would be something that would be more convenient to use. So maybe more people would start to prefer 3D printed food compared to regular food as well. And that's when we'll have 3D printers in every home.
Let's try and squeeze in another question here. So Vin Sri says, I've heard of personalized medicine, but I didn't think personalized food is a thing. Could Anirudh or Lee Manwai please explain, apart from small specialized needs, is there a business case for 3D printing apart from niche hobbyist usage?
Well, from what we believe, basically, all our consumers are actually getting more health conscious in terms of their well-being, and everyone has a different requirement and in terms of needs as well. So if we could eat foods rather than eat medicine, I think it's something that is much better, and it will be it gives you the mindset they are actually not so sick after all, because they are consuming food as part of medicine rather than using medicine as a personalization format. So we do find that people are really looking into using food as a form of the new age medicine in that sense, where they actually feel that they consume food as a form of medicine as something more palatable compared to popping in pills that is specialized and personalized for individuals. Yeah. So we are trying to harmonize this, getting health and wealth from basically a diet.
And of course, when we talk about nutrition as something that we use for maintaining health, it's basically prevention, and prevention is always better than cure. So initially we may be focused on the most dire situations, but eventually we can have more wider acceptance where people who are not sick or who don't have any special needs also go for personalized nutrition, just because it makes life easier and healthier for them.
Excellent. Okay, so we're getting towards the end of our allocated time today, but just as a final question for the panelists, if you could sum up the future of food in one word, what would it be? So, Anirudh, please.
Well, one word is too little. I would just say exciting, I guess.
It will be a journey.
Journey, exciting journey.
Surprising.
Surprising. And a surprising, exciting journey. Well, I hope that's what we've had a little bit of today. I thank you very much for all the panelists who joined us, and also for the audience with some very interesting questions. And I can certainly see this as a topic where there's much to discuss, and I'm very intrigued to see where all of your work is progressing. So thank you everyone who turned up today for the discussion, and again to the panelists and of course our hosts at SGInnovate. And on that note, I'd like to hand back to Jin for final words, please.
Michael, and thank you to our panel of speakers for the great sharing as well, and everyone for your ongoing questions. It is always very heartening to see so much enthusiasm in our online sessions, but real conversations often happen after, so we do hope that all of you can keep connected. So we do have a recording of this session, and it will be uploaded onto SGInnovate's YouTube channel next week, and the embassy will be posting it on their channels as well. So do head on to our platforms for a review of today's event. And till our next online event. So thank you everyone and goodbye.
Bye.
Bye.
Bye.